Okay, in this video, what we'll do is we'll talk about overriding some of the process parameters. So we'll go back to our last example. And in this example, what we did was we defined a list of vehicles and we simulated that list of vehicles. One thing that we can do is decide where the vehicle results are written, and that can be done through the interface of add run vehicle process. So when we're adding the single run, add cycle or process. So when we're creating a single run and we're assigning a cycle to it, when we are assigning this cycle, what we can do is we can overwrite some of the properties that are on the underlying process. So here we're overwriting the class, but we can also the cycle. But we can also do is we can overwrite some of the properties. So what we can do is set the properties on the process. So inside here, what's really being created is it will notice that, oh, you're setting an A cycle. So what it's doing then is it's creating a internal representation of running a cycle, which is a PXF run cycle class. So some of the properties that you can set on PXF run cycle are the properties that are listed here. So some of it is, oh, where is the model saved? If there are configuration options, if we're doing SOC correction, if you want to, do some type of signal logging or change the workspace sample time, or if you want to turn off saving the HTML report or the init map or some of the data files that are created when running a simulation. So those are all accessible through the interface on PXF run cycle. And even with PXF run cycle, there's classes that are created. If we create a PXF run cycle and then we do initialize using defaults, you can see that there's this directory manager that's created that has a lot of the information on where the results are being saved. So we could look at, now we're seeing the properties here. But one of the properties is this override save path. So this is basically telling the simulation where to save its results. So by default, it's creating a folder that's based on the vehicle file name, the cycle that you're running, and the run number. So some of those properties, but all that can be overwritten by the user by setting override save path with this value. So the way you can access that through the interface is we're basically saying, okay, on this vehicle, set this cycle. But then what we want to do is we want to pass in the path to this property. So it's going to be on the cycle. So it's on the directory manager. So we want to put the directory manager on there. So we're accessing this property on the cycle. And then this itself is a class. So then we're going to access the property on that class, the directory manager class, which is this override save path. So I place this here. So what we're doing then is we're saying, okay, when we're running the FUDS cycle, we're going to set the directory manager, we're going to set the save path. And where are we going to save it? We'll save it under C:\\. We could do Amber development and then create a results folder. And then let's just, since each vehicle simulation is unique, we're just running one cycle on that vehicle. What we can do here is we could do file parts on the vehicle list. could use this file name and just append it there. So what that will do is it'll then save the results directly into a folder, C Amber development results file name. And we could up the number of concurrent processes, make it 6. Using the local profile, distributed computing, so we're using the parallel computing toolbox that's provided by MathWorks. So we're using this parallel computing toolbox. So that's why we have distributed on is equal to true. We have the number of parallel runs set to 6. We're using a local profile. We're going to get the results. So what I'll do is let this run, and then we'll come back and look at the results. You can see the simulation starting, and then I'll run 6 concurrent processes and save the results into the C Amber development results folder with the vehicle file name. We have different models. You can see here we have 6 Simulink diagrams matching the number of requested parallel sessions. So we'll let this run and then look at the results. Okay, now that the simulations have finished, we can go to this folder location, C Amber development results. And we should see a separate folder for each simulation result, which is what we see here. So we see the belt integrated starter generator mid-size, and the 8-speed, the CVT 6-speed crank integrated starter generator. So we see each of the vehicles that were in the list got saved to its own file with all the artifacts. So that's one quick way that the user can decide where the results are being saved by overriding the save path as one of the parameters and direct where those results are being saved.